Hi everyone and welcome back. Welcome to Node.js microservices for building the products. So in the last couple of videos, we were talking about Express TypeScript APIs, like how to build a microservices using Express TypeScript and MongoDB. Now these are like four major sections in this module one. This we have already covered. So maybe I will just colorize this and I will move to back. Okay. What happened to this? Then this is what we are going to talk about. Now we can just pick this Express TypeScript MongoDB APIs and we will try to add a 12 factor principles, which are nothing but we will try to explore what are these 12 factor principles and how we can apply to make our application real production ready, right? Which can have a multiple environment, which can have a runtime configurations, which can have a proper logging, port binding, disposability, dev and production parity, log management, admin processes, and some kind of a process manager to check the Node.js processes, health check, version control, how we are deploying it through the different CI/CD steps, what are the different processes, port binding, concurrency. All those things are part of this 12 factor principle. This is what we are going to discuss. Okay, I will just try to move it, and then once this is done, because we are going to apply the same stuff to the nextjs application, so here also we are going to do the same process. And so these are the three sections which we are going to talk now, right? Once this is done, we will talk about few videos on the nextjs baseline, because people might not be familiar what nextjs is. If you are already done, that's good. How to build a nextjs controller services and APIs using nextjs TypeScript. So we can just take an example of auth service, maybe auth microservice, and build it with the nextjs. And then we will talk about how to add these 12 factor principles, how to apply 12 factor principles on any nextjs microservice, because the end goal is building a production ready microservice. So let's talk about this. So in the 12 factor principles, these are nothing but we already know all those things. They are just like characterized with the 12 sections. So you are calling 12 factor principles. So the first is the code base, because these are not only theoretical, we are going to see this in our code base also. So code base like it's all about version control. Whatever the version control you use, we use a git, and then how we are going to deploy the same code base to the different environment. We need to have a proper branching strategy. Even if you have a different dependencies on different packages, then how we manage them. So we can try to understand it something like this. This is your code base. Let's say here you have your APIs or service. Okay. And you might be deploying this service to the multiple environments. So what you can do, because we are using Git version control system, you can have branching. Okay, I have a develop and then I have a different branch. Let's say I have two environment only, dev and master. So whenever you push or merge anything to develop, then it is going to trigger a CI that is going to deploy things to the dev environment. And when you push something or merge something to the master, then it is going to deploy things to the production. Right? So this kind of a branching strategy, let's say if I want to build a new feature, you will always check out from this master branch, build your feature, feed new APIs, something like this, and then you merge this new feature back to develop. This is how you will propagate your feature to develop, and then maybe you can consider develop as your trunk and then merge either the same feature branch, or maybe you can try to synchronize the dev with the master. So there are different branching strategies. That is totally different topic. You can just go ahead with this only, like you just because there may be a multiple developers working on different features. So you check out from the master, like feature 3 feed auth APIs, right? So this developer will also do that. It will check out from the master branch, and Once the feature is done, you will merge to the develop. And if there is any conflict, you can create a temp branch, and then you will merge the temp branch to the develop. And then same feature runs, you can merge to the master, right? So once this you merge it to dev, everything is good, you deploy it to the master. So this is how you can manage the different environment. It's only about your CI/CD configurations, that when you merge it to dev, deploy to development, when you merge to the master, deploy to the production. So it's all version controls which you can control through the CI/CD. And here we are already using the monorepo and the packaging systems. That means here you can see the packages. So we can even divide the packages, because these packages can be published independently, and you can even change the versions. Okay, 1.x, 2.x, these are like the npm packages. You can either publish them to the remote and can also be used locally, right? So in that case, you can actually use different package versions across these different applications. Let's say you have here, what do we have? Database. So this is the current package name is 1.0.0. Currently we are using, because this is a workspace, so we are using those packages directly into our application, but you can also publish them independently, and you can start using them by importing the packages from the remote npm. So that is all about dependency management. Like, okay, your two applications can depend on two different versions of the same package. That's all about how you manage the dependencies. Next important aspect is the dependencies, right? So whatever we are declaring as a dependency to our project. So here you can see this is our root package JSON, which is nothing but a global dependencies. And then if I talk about this application, I can create a copy of this and I can play with this, renaming it as a 12 factor express TypeScript Mongo APIs. Right, and here we can do the changes whatever we want. So this is our package JSON. Here you can see all the libraries. Dependencies are like core dependencies, and the dev dependencies are like the where you are adding the types, the dependency for the testing, dependency for building the code, but all the code dependencies will go here. So here we need to make sure that we have correct and appropriate version of the dependencies added in our package JSON. So here you can see in the root package JSON also we have the dependencies. I mean, mostly all the dev dependencies, because there is no project. It's a root dependencies, root level dev dependencies, which are just talking about TypeScript, commit lint, Husky, commit conventions, for ESLint dependencies, and for the test. Okay, here you can just do a npm install. So it will install the dependencies in the workspace in all the projects. Let's say this is my project which I'm just checking right now. I need to add a couple of more scripts here so that I can have all those things. But here you can see the dependencies and dev dependencies are totally isolated. I don't have a ESLint dependencies and all, because those are already declared at the top. Otherwise, if you are just writing a single application, then you would be adding ESLint and lots of configuration, lots of dependencies in the dev dependencies. Okay, so this is pretty much straightforward, like how we are managing the dependencies in the different programming languages. They manage it differently. Like there is a Ruby gems, and then in the Python there is a requirement.txt. there you declare all the package and their version names. So these are the versions, right? So here you can see 3.0.0, 1.4.3, 4.17.17, all these versions. So this is the major version, minor version, and the patch version. And here we are allowing, so there are different symbols you can use in the package JSON dependencies, right? Here I'm just specifying 2.0.22. So this upper arrow specifies that if there is any stable release after this patch version, then it automatically upgrades. Okay, if you are just fixing the version, something like this, that means no matter what happens, it's not going to upgrade your dependency internally unless you change the version name explicitly. Now the next important part is how we do the config management and how we are going to get the secrets. So this is always really complex, or I mean, it can be as simple as you want, or it can be as complex as you want, because these are like environment variables. So this is like my service. Okay. And if I want to develop this service locally, what we do is we just have a .env, and we most of the time we have env.example file. I mean, this is same for any other programming language also, the runtime environments. Okay, I need a database URL, or maybe some access key and secret key, like AWS access key and secret key for the backend APIs. So we just manage them through the .env.file, and we use this particular package .env.config to load the dependencies, so that all these variables, whatever you are declaring inside this, something like this. So in the variables, we are just putting database underscore URL equal to something. Okay, access key equal to something. So whenever you do .env.config in your root file, in the main file, then what it will do is it will actually populate all those things inside your process.env. Now you can access them using process.env database underscore URL, or you can do process.env access key, something like this. Okay, this is a way of doing it. Now this is not happen on the production or any deployment environment. What happens is you don't have a .env file in the code base. .env file is something which you just manage for the local development, where you can just populate your local database URL and connect and test the APIs. But what happens for the production? You cannot just put .env in your code and then people, I mean, obviously you cannot put .env which contains the database URL which is secured string. So what we do is, there are many ways of doing it, and there is no specific way of doing it. There are n possible ways. You can have a CI/CD pipelines, CI/CD, which does the deployment to the environment. So either it is a, let's say I'm deploying it to the EC2 instance, or maybe to a container. So container is totally secured. You cannot access it directly until unless you have an access. So no outside person can access it. The only thing we need to do is, while deploying it, we need to put all these variables, and these variables are configured in the CI pipeline. Like in the GitLab CI, you can add the variables which are secured, and while deploying it, it will pick those variables, and then it will populate those variables in the process.env of that container, of that EC2 instance and container. Other than that, there are more secured ways, and that is, let's say I'm deploying it through the container or something. Here we will just CI/CD will just deploy the code, and at the runtime, when you are actually bootstrapping the application, then you can actually manage these CI/CD variables, because this is really important topic. CI/CD variables, you can fetch these from the external third party, and now these third party can be AWS SSM, secret manager, which can actually secure them, put them secretly, which you cannot access until unless you have access. And then this container at the runtime, when you are bootstrapping the application, will get the data, and then you just populate them to the process.env, and then your application will start having access. So like production database URL with the username, password, and everything is there, right? That we are just reading from the AWS secret manager. And at the runtime, when you are actually doing node index.js, at that time you fetch this, put this in the process.env, and then use it. Other than that, there are other third-party platforms available which can store the data, like even 1Password also. 1Password provide the APIs which you can read at the runtime through your code before bootstrapping. So before even you connect to the database, you will always have a database string, database URL. Okay, so there are many ways of doing it. The simplified way is we can just try with this, like GitLab CI variables. and you push those variables, and then before even application starts, you populate those variables in the process.env. Okay, and then once application start, it already has the variables, but here we are storing the variables in the secret way in the GitLab CI, right? This is the one way of securing it, but obviously whenever it comes to securing some critical information, then obviously you can use AWS SSM or secret manager and let your runtime or let your application bootstrap fetch those information and populate that in the process.env. Okay, that is all config management. And apart from that, this is all okay. I have a .env. How we manage the multiple environment, because obviously when you are deploying, you already know either you are deploying it to dev, QA or production. So obviously you will be picking up the right configuration, right GitLab secret variables. In the GitLab, you can actually segregate these environment variables based on environment. Like, okay, I have a dev variables for this application. I have for the QA and for fraud. And you can pick whatever is requested in the CI, not like, okay, randomly QA and production. So this is how you can segregate. And for the local development, if you wanted to switch, then there is always this king process.env.node.env. This you can have as a process variable, which tells you, okay, what is the environment variable you are looking for. You can have a development, you can have a production or staging. So based on this variable, which you are going to set on the app bootstrap script. Okay, if let's say I'm just deploying my application or running my application for the development, it will pick. And then obviously if you want to have something like this and you wanted to have a separate file, then you can have a something like env.development, env.production. Obviously you won't be accessing the production config locally, but this is how you can test the production setup or development setup. And in the .env is a module, right? Here you can specify which file to load. So first you will check, okay, what is the process.env.node.env. If it is development, load the env.development. If it is a production, load the production env file. I mean, currently in our code, we just have a env example. So we'll just create a .env from this. And we already have this file, which should be in the server.ts. If you see on the top, .env config. So it already knows, like, okay, I need to load the configuration from the .env. So it will look for .env file in the root, and then it will populate these values. Like it will populate Mongo URL in the process.env, so that my server.ts, which is calling app.ts, can get the MongoDB URL. Okay, because Mongo URL is already there in the .env, so it will pick it from there. There may be anything, access key, secret key, like JWT access key, JWT secret key is the file. Something like this you can add. And if you see here, I might be using this thing somewhere, access key and the secret key, while generating a token. Okay, jw.verify secret is coming from, you can see here, process.env.secret. So the secret name is secret here. I will use this, or we can just replace it with the secret key. That's appropriate name, right? The correct naming, JWT secret key. Okay, so this is how you can manage you can use the .env and you can switch between different environments. So here we can add remaining scripts. So we are in this project. I can just try to run these basic scripts like npm run build. What it will do is it will just look into the tsconfig file and it will target is ES5. And here lots of things you can play with, right? Because this is a TypeScript. Let's say if you are putting ES 2017, and you are doing build, then it is going to give you the TypeScript in the output, right? If you see the server.js, you can see the import statements are still there. And if you try to run the project like start prod script, npm run start prod, you will get this issue, right? Because you cannot import, you cannot use import in the ES5 code. Here you are running a JavaScript file, the output JavaScript. So you can just make it as a ES5, ES 1015. I think that would also work. We can just build it again. And here in this dist folder, server.js, this is still looking ES6, right? So let's make it ES5. Now I will build it again so that we can start it using npm run start prod. Yeah, it works because now it is looking for this connection string, but application started, right? So this is what we wanted. And why I'm talking about this particular thing is because I have added this package script here, and where I'm passing node env. So let's try to see what is the node env value we are getting in the server.js. Let's say if I just try to do console.log, process.env.node.env, and if I try to, we can run this also instead of building and starting this again and again. Start prod, so you can see it is using development. Let's say here you can switch to different environments. Here package.json, here you can just do is a build qa build prod, start dev, start prod, and if I do start prod, what it is taking production. So this node env can be set in your script also. So because here based on the node env we can do lots of things. We can check here if process.env, because the same thing will be captured here also. Here you can just do is process.env.node.env equal to development. Then you can load a different file, else load a different file. This is something which you can do, and how we can do that is done with the .env module. What I remember is in the ES5 we used to do something like this. So the same thing, you don't even need to worry about this. We can just put the whole thing in a one line, right? What we are doing here is require.env config is .env.development. So we have a .env.development and .env.production. This is how, this is locally, and we don't do it generally like this. We always play with one environment on local, and for production we don't look for env.production, but this is just in case if you wanted to switch between different environment based on this, then you can just pass this node env while running the script. So it will set it to the development and production, and it can pick the appropriate file from here. You can see .env config, the path is this .env.development, .env.production, and both set of files you have here. So this is all about configurations, like how you can manage the configurations for your project. And in locally you can switch to different variables, different env files. Like if I wanted to test my production, then you can have something like this, but always make sure that node env is pointing to that environment. In production, and when you do a deploy, we always put these configuration variables, okay, because in CI/CD it knows you are deploying to dev, production, or staging. So it will pick the appropriate CI variables for the dev, CI variable for the production, and then those variables only will be populated to the container, to the Lambda, to the EC2 instance. Okay, this is how we manage the configurations. And in the locally in the code, managing configuration is kind of simple. You manage the env example to tell the developers, okay, these are the different environment variables we have in our application. So make sure you have that in the env when you are running the application. So this is the first video. Now let's see how we can manage the logging, how we can do the logging as a production application, and how we can deploy the application using GitLab CI or something, and how we can manage these different environments through the branching strategy. So we will do a little bit of demo in the coming videos for the same.